So the first thing that you need to know is what a solute is versus solvent. So a solute is what is being dissolved, and the solvent is a substance in which a solute is dissolved in. So yeah, and dissolving takes place on the surface of the solute. So this is a diagram for saline water, which is sodium chloride and H2O. So yeah. As you can see, the ions are being separated by H2O molecules. The partially negative and positives are being attracted to the positives and negatives of the ions. So yeah, and those form when the molecules surround them. That forms a sphere of hydration around the ion. So, and how you can tell which one is, more partially negative or positive if it's not H2 as a solvent is if it has a greater electronegativity. So basically if it's closer to fluorine, it'll be partially negative, farther, partially positive. Polar water molecules are attracted to the solute particles and pull them apart, as you can see here, as just a generalization of it. And then so if these are solutes, molecules will separate from other molecules, and ions in an ionic compound will separate or dissociate. So dissociate is the same thing as separate, except it's a specification to ionic compounds in water as the solvent. So yeah, and as you can see there, the strength of the attraction between ions and the H2O is stronger than the attraction between the ions themselves, and that's evident because the ions are the ones that actually separated. And the reason behind that is because there are many more water molecules than solute ions, so there's much more solvent than solute, which is why it's able to break apart those ions in the ionic compound. So some terms, solvation is the surrounding of the solute particles by the solvent particles. So as you can see here, the solvent particles were surrounding the solute particles. Hydration is the same thing as solvation, except it's when the water is the solvent, so it's like a specification of solvation. And yeah, so an aqueous solution is a solution with water as a solvent, so it's like the same concept here, except hydration describes like the process of it happening kind of, and then aqueous describes the solution itself. As for liquid and liquid solutions, we have two terms, miscible and immiscible. Miscible is when two liquids are soluble in each other. So for example, water and most alcohols like ethyl. And then immiscible describes two liquids that can be mixed together, but then they'll separate shortly after, so they're not soluble in each other. So for example, oil and water. So dissociation involves the separating of ions in an ionic compound in water, as we said before right over here. And yeah, so the dissociation equation represents the separation of ions in a solution where the solute is an ionic compound and the solvent is water. So for example, using the sodium chloride, the example that we used before, this is what the equation would look like. And this is what it will look like for like a lot of other examples as well. There's three things that you have to remember. One are the phases. So like these little subscripts right over here in parentheses, S is for solid, G is for gas, L is for liquid, and then AQ is for aqueous. And as we said before, we know an aqueous solution is a solution with water as a solvent. Because you have to remember then that once you put it in water, it's not just sodium and chloride, it's sodium chloride, but it's in the water because the water attaches to them, forming spheres of hydration. So you need to put that instead of S, G, or L as the phase. It's AQ, aqueous. So yeah, and the other thing that you can't forget are the charges. So like here and here. Here it's neutral, but once they separate, they've got their positive and negative charges. Again, that's why the spheres of hydration are able to be formed, because of that attraction between the positives and negatives of the H2O molecules and the positive and negatives of the ions. So yeah, this side of the equation basically is before water. The reactant side, it represents after it's in water, dissolved. Also, polyatomic ions don't separate, so NH4 does not become N and H4. And another one is, so you can't write NH4 as 4NH because there aren't 4 N's, and so just don't make that mistake. So yeah. So the rates of dissolution, dissolving, are all about how fast and much the solute can come into contact with the solvent. So one is stirring the solvent, which increases the kinetic energy. So the solute contacts the water at a faster pace, and that way it can separate more quickly. And then 2 is increasing the temperature, which will also increase the average kinetic energy. So the solute will contact the water at a faster pace once again, and so the solute will separate more quickly. The third one is decreasing the particle size. Many small particles instead of one large clump of one, so that increases surface area, which we know will increase the rate of dissolution, which is dissolving, as we said here, because dissolving takes place on the surface of the solute. which means that there'll be more places for the solvent to come into contact with the solute, which will increase the rate of the solution dissolving. So for example, sugar granules versus cubed sugar, the total surface area of the granules is greater than the surface area of the cubed sugar. So as you can see, there are more places for the solvent to come into contact with the sugar here. And yeah, it's kind of like helps it dissolve in a way by breaking it down, you know, like that's what it does kind of for it. So yeah, thanks for watching.